Let us talk briefly about another force that is associated with liquids at rest. Capillarity. Capillarity is defined as the tendency of a liquid to rise or fall in a capillary tube. A capillary tube is more like a pipe which is often open at both ends and has uniform size throughout its length. For example, the straw with which we take our soft drink is an example of a capillary tube. Also, the tube that houses the ink in our pen is also an example of a capillary tube. Let us now consider the actions of water and mercury in capillary tubes. The action of water in capillary tube is demonstrated using 6 capillary tubes in this picture. In this picture, we can see that the 6 capillary tubes are of different radii. The number 1 capillary tube is having the highest radius, and the capillary tube 6 is having the least radius. Now, from the picture, it is evident that the water level in each of the capillary tube rises above the water level in the container. And as you can see, the height of water is highest in capillary tube 6, which has the least radius. And the level of water in the first capillary tube is least because of its wide radius. So therefore, we can say that the tube with the smallest radius has the highest height, while the tube with the largest radius has the lowest height from the water level. The action of mercury in capillary tubes. For instance, if this is the original level of mercury in the tube, then for mercury, the level of mercury in the tube is lower than the mercury level in the beaker. That means a depression is experienced in each of the tube. To explain this better, we will see that this is the original level of mercury in the beaker, which is marked by this line. Now, a depression is experienced in the tube, which is lower than the original mercury level. For tube 2, a depression is also experienced, which is more compared to tube 1. For tube 3, a depression is experienced, which is more compared to the initial 2 tubes. For tube 4, a depression is experienced, and on like that till we get to tube 6. Now we can see that the lower or the smaller the size of the tube, the more the depression. This is to say that the depression experienced by mercury in the capillary tube is higher in the smaller tubes compared to the larger tubes. That means tube 6, which has the smallest radius, experiences more depression of mercury, while tube 1, which has the highest radius, has a lower depression. But a good fact to note is that each of the tube experiences depression of mercury as compared to the original level of mercury in the beaker. To broaden our understanding about the action of water and mercury in capillary tubes, let's take a look at the picture before us. The A part of the figure describes the action of water in a capillary tube, while the B part of the figure describes the action of mercury in a capillary tube. Let's start from the A part. The action of water in a capillary tube creates a meniscus that is concave to air and convex to the liquid. For the B part of the picture, talking about mercury, a meniscus is created which is convex to the air and concave to the liquid. The application of capillarity include but not limited to the following. 1. Ink held on the nib of a pen. 2. Rise of liquid up sugar cubes. 3. Water rising up the stem of a plant. 4. Use of blotting paper to absorb liquid. 5. Kerosene rising up the wick of a lamp or a stove. 6. Liquid candle wax rising up the wick of a candle. And 7. It can also be seen in the circulation of blood in our body through the capillaries.